All right, so this is going to be the second week of demos related to audio, reactive, visual music, that sort of thing. Based on what people voted for in the poll this week, we're definitely going to cover Lucid Sonic Dreams, so we'll take a look at that probably next. And then I made a demo of how to connect ML5 with audio reactive stuff using p5. So that's a little bit, it's not exactly what we talked about in one of those, but it's sort of like similar, and I think it'll cover some cool things. Uh, excuse me, for anything we didn't get to that was on the list of poll stuff, I will definitely get to that over the next couple weeks. So just keep an eye out for that, and if it's something you really want to work on as soon as possible, just let me know, and I can try to prioritize that. But we will cover many of those things. So no stuff like basic object detection. We have, actually, you might be able to find that the ML5 stuff works well for that. I don't think anyone asked for Librosa, which is totally fine, but we can look at some other audio. I'll build up some other audio tools over time as we're starting to play with more of these things. So I'll also say I think we're like, this is halfway through the class, right? Is this week 5? So we are halfway through class. And just as a reminder, in week 10, even though there's a break week, we will be doing a demo, like show and tell kind of thing. So if you like one, you're more than welcome to just like play with the demo that we already play with in class and show it. But if you have an idea for a bigger project, start to think about what that might be. We'll do a couple more demos over the next couple of weeks on some other things. But if you found something you liked working on now, you can more or less jump in on that, and I'm happy to help through co-working sessions how to do that. So just keep thinking about it. Again, there should be pretty low stress. Like there's no like final exam or anything like that. Just make something that you're interested in working on. And depending on how much time you have, like that could be big or small. So just keep it in mind and give it a thought as you work through stuff for the rest of the week. All right, so with that, let's start with Lucid Sonic Dreams. We'll share my screen. And the other thing is you should have a short audio piece to upload. So if you don't have that, quickly like find a short little thing, like 30 seconds or so, to grab right now. All right. So, I know a couple of you Hacktive tools, and you, if you're familiar with stylegan, you probably have also heard about Lucid Sonic Dreams. Lucid Sonic Dreams is just it's a, it's a slightly different take on how audio reactive tools can work, but it has a lot of overlaps. So let me just pop the link to this into our chat for everybody. And so the idea here is, I know not everyone has taken a stylegan class. We'll probably cover a little bit more stylegan stuff maybe in the last week or two of class. But stylegan essentially is a model. It's a generative model that allows us to manipulate imagery based on sort of what we would call a vector space. So imagine you've got like a 2D grid of images, and as you move left or right or up or down, the images morph and change from there. And because it's based in this space or a grid, you'll often hear it called the latent space. Because of that latent space, you're able to manipulate all of these numbers based on essentially other data, right? Because they're just numerical values. You can use other data and other numerical values to move them. So the way that this works is that essentially we'll process some audio. We'll be able to tell when things get louder or quiet, or when a pitch changes or that sort of thing. And because of that, we'll then be able to manipulate the latent vector and therefore produce different images. So I should say, if you are really interested in the more advanced version, I'll post a link to the video that we did for the advanced stylegan class. That one does require a little bit more technical knowledge, but we sort of cover it in that class. So if you are interested in something where you get really fine-tuned control, you should look at that. Laura, it's fine if it's 30 seconds or longer. I think it's just, particularly I should say with this notebook, if you are on a K80 or other slower machine, it just is kind of slow to produce images. So it'll be fine. You just have to wait a little bit longer for a longer video. So with that, if everyone wants to open up that Colab notebook, we can get started. So the first thing I'm going to do is I'm just going to drop a audio file into my notebook here. So I went ahead and saved one previously. I got to tell this thing that yes, I'm not a robot. All right, so let me drop in my audio file here. There's this one. So two other notes about this particular notebook is there is the person who made Lucid Sonic Dreams also made their own notebook, and it's actually very well documented. So if you want to read through what they wrote in theirs, I definitely recommend checking out this notebook. I've sort of structured mine a little bit differently, and I've maybe cut out some of the uh, other sections that he's included. But I would just say like you should, and I welcome you to read both of those. Um, One because most of the stuff I cut and paste into this notebook came from there, but I'll also sort of talk about my own approach. The way I think that works best for doing any audio active stuff is to begin to individually uh, basically isolate individual variables and begin to play with those and see how those work before you add them all together. This will make sense in a little bit in a second when I show how everything else looks. But let me just, there we go. Also, I couldn't see everyone, so I can see you all now. Cool. Okay, so the way Snowbooks works is hopefully you've uploaded an MP3 now. It could also be a WAV file. I think it doesn't really matter what kind of file format it uploads. I think it'll just sort of figure it out, but I uploaded an MP3. So let's just check to make sure that we have a GPU working for us. Cool. So I have a K80, which I believe is the worst available. So if you have a K80, you'll also be fine. This notebook will work totally fine. It's just slow. So what I'll do for the demos is I'll do a really short clip. And then what I've included in here as we go through the notebook are I have a number of YouTube videos. So basically last night I went through and ran this. So I have longer examples here on YouTube. So we'll actually just play these videos. It's actually pretty easy to watch a YouTube video directly from this. So what I'll do is I'll do a short little clip and then we'll watch what a longer clip looks like. Okay, so let's go back up here. So now that we know we have a good GPU, let's just go ahead and install all these tools. So that's what this cell will do. And for this demo, we probably don't need to worry about installing Google Drive. But if you're going to generate a bunch of video files, you might find it's helpful just to drag all those video files into Drive once you're ready, because downloading is just always a little bit slow through Google Drive, or sorry, through Colab. I'll skip this for now, and we'll come back to it. So the first thing that we need to do inside of anything with stylegan, we have to find our model file. So if you've taken a previous class from me, you know that we'll often train our own model files. For this demo, we're actually just going to use some pre-made, pre-trained models. And the way we can do that is this uses, many of you have heard of this before, but the awesome pre-trained stylegan 2 collection. Oops. Let me drop this in here for everybody to take a look at. So this is a bunch of publicly accessible stylegan models that people have uploaded to Justin Pinkney's GitHub account. So if you want to basically the way what we can do is you can just go through here and pick one you like. So if you want to generate some cars, you can generate some cars. If you want to generate some cats, there's some cats, churches. So there are a number of openly usable model files here. The one we're going to use is actually one that I produced and uploaded, which is the abstract art one. That's one I'm going to use. You're welcome to use whatever you want. So we'll do one with some weird abstract art things. So the way to find what models are available through this is to run this cell that's from Lucid Sonic Dreams import show styles. So if we run this cell, Come on. Notebook or my Chrome. Yeah, I'll drop the link to it for you, Michael. There you go. Okay, so once this runs, apparently it also installs some stuff. But once this runs, you'll see there's a list here of files. And you should be able to map these names fairly easily. And I say fairly because it doesn't always map exactly one-to-one. But if you go to the top of this page, you should be able to find each link here. So let's see. So what are we looking at? Close that one real quick. So for painting faces, let's see if there's one called painting faces in here. Painting faces. And so that's faces that are painted. So you're welcome to grab whatever you want from this list. You can also, if you're interested, I trained this model for a class the other week that I was teaching. So you could also download this trees model if you're interested in it. So pretty much also if you have your own stylegan model, you can also import your own. You can do pretty much whatever you want with this. For this class, I'm just going to take this abstract art model. So we'll use this string, and I'll show you where to put it in just a minute. But there's a ton of options here, and I definitely recommend, like, maybe when you come back to play with this later this week, that you maybe look through what your options are. Maybe you want to do a My Little Pony audio reactive animation. Okay, so copy whatever name of your file you're going to use, and then we will go ahead and drop this into this model. So the very basic version of this tool is that you give it a song, you give it what model you're going to use, and then you can pass in some basic parameters that what the model will then, or what this tool will do is it'll take some of the features of your song and then apply it to your stylegan model. So the first thing we're going to do is we'll take that string for the style that we took, and we'll paste it into this fourth line. So where it says style equals is we'll do this. And then for the song equals, what you're going to do is you're going to grab the song from here. So we'll copy the path and we'll paste it in here. So all this does is sets up a class and just says we want to use this model and we want to use this song. And then from there, what we can do is we can pass in some arguments or some variables to change our model. So the first thing is you can set a start. So let's say you want to start 30 seconds into the song you uploaded. If you said this is 30, then I'll jump 30 seconds into the song, and we'll start there. So with this particular song, I'm going to start at 0. Then is duration. So both these values are in seconds. So if you want it to run for 30 seconds, starting at 30, you go 30, 30. So because this is a little slow, I'm going to do this at just 10 seconds, just so that way it's not running too slow, or we're not sitting here waiting for it to load. We will cover most of these variables in just a minute, but what I will say is speed FPM is how many different images you want to start with. So basically it'll pick 12 random images from your model, and then it will interpolate between them. So this is a variable of 12. So if you set this to actually be 0, you will get no change. We'll just pick one image, and then you'll get minor modifications from that image. If you pick 4, it'll be a little bit slower. The default is 12. So basically what I say is, like, start with all the defaults on and just sort of work off that. Next, you'll see here there's pulse percussive and pulse harmonic. What that does is this is a pulsing rhythm. So this will look for some pulse in the song, and then it will apply it to your model. So your model, like in this case, we've set pulse percussive to be true. So when we hear a kick snare, or like a kick drum, kick drum, you're going to see the image sort of like do this. So that's what pulse percussive does. If you were to set pulse harmonic to true, it would look for the harmonic values in a song and try to pulse off of those. By default, they sort of recommend you start here. That makes sense because drums have that sort of pulsing range. Next is pulse reaction. We will look at this a little bit more, but this takes a value between 0 and 2. 2 will give you really strong pulses, so like any kick drum, like the whole screen will like kind of freak out. 0 will do nothing, so if you wanted to turn both these two off, you would just set this to 0. And right in the middle is 1. So we'll start with that and just sort of see what happens. Next are motion harmonic and motion percussive. This is sort of the opposite of pulse and pulse percussive and pulse harmonic, where this will apply a motion. This is actually animating the interpolation. So if you set harmonic to be true, it will look for the harmonic values of a song, right, the melody, and try to apply the motion to the melody. And if you want the motion to be applied to a drum, you would do motion percussive. Gotta say, I don't really think this would look good if we flip these two values, but they're settable. So if you want to play with it and sort of see if your particular song works well with that, it's good. Lastly, I include this random seed. I was trying to get more control over the randomized images, but I don't think it works, and I have to come back and see why that is. So you can sort of ignore random seed for now. One of the things I will say is I was trying to fix that because one of the common complaints about Lucid Sonic Dreams is if you find a video you like, the next time you run a video, it'll be completely randomized again, and you will like kind of be annoyed that you can't go back to the video you had. So I was trying to fix that here. Didn't get to it yet, but I probably will this week. So let's just go ahead and run this and see what happens. So I should also add, one thing I didn't add is file name. This is where you output your file to. So if you leave this name as is, that'll be totally fine. So we're going to go ahead and just run this cell. And if you remember the audio reactive stuff that we were looking at previously, you know it was a lot harder than this. Here you're just setting a couple variables and letting it run. The downside I will say is that I don't like the results as much, and we'll look in the next like 30 minutes, we'll figure out how to make that a little bit better. So I will say the audio reactive tools that we looked at in that advanced stylegan class, you have much more control, but you definitely need to know what you're doing. Whereas here you can just sort of play around with the values a little bit and get something cool. And I'll show you some tips to make it even better. So that's kind of the difference, is like there's just a trade-off of how much control you want and how much time it takes to like sort of learn the basics versus just getting to be able to run something and seeing what happens. So now that we've run this, we will see that we are now producing a number of outputs. Oh shoot, you know what? Well, let's see how long this takes. One thing I should note is that by default, for some reason, these videos generate, they're 43 frames per second, which seems high to me. I mean, it's probably better. It gets you a little bit of a nicer animation, but that also just seems really high. So if you want to change that, and you haven't run the cell yet, you can add in another variable here to say FPS equals 24, and that'll convert it to 24 frames per second. So now it's generating my frames. So you'll see it wants to produce 431 frames, and now it's going through and producing them. So this is quite slow, I would say, on a V100 or a P100. This should be about double or triple this speed. It looks like it's going to take about a minute to generate my 10 seconds of frames. That's fine. It's not ideal. It's a little slow, but for a free collab notebook, it's pretty nice. So we'll just let this run for a little bit, and when it's done, what I'll do is I'll actually just play the video below it, and we can sort of see what happens. What I'll say is when this finishes, you might want to look at your own video and see how your own song applies to whatever model you picked. And let's see, where did I save this to? So save this to content/basic LSD. So there should be, when this finishes, there should be a video here called basic-lsd.mp4. Okay. So now it's generated all my frames. Now it's just gonna store them. I believe it makes a little temporary folder called basic_lsd_frames. And once all the frames are stored, then it can generate the video from that. Ben must be on a faster machine. He's already getting good stuff.
I pressed the button early.
Good man.
It's very colorful, very shapy.
All right, so we're almost finished here, so we'll go ahead and play this. Going forward, I'll make sure we set it to 24 frames per second so it's a little bit faster. So while we're waiting, I'll just explain what's going on here. So this is a cool little um, function that allows you to play YouTube videos directly inside of Colab. So I think Michael and I were talking about in the chat the other day that you can play a video directly, like you can play a video through this and it'll play in here. The problem is that I find that it's pretty slow. It takes time to render all these things as individual frames and then play it. But YouTube is actually really fast. So this is the YouTube ID. So if you go to like a YouTube channel, there's always an ID for each video. So if you just put the ID in here and then run this cell, you'll get your video that's from YouTube. So here it is. So this is, we'll talk about what separated is versus unseparated in just a minute. But this is my basic video for this demo. So let's go ahead and play it and watch it. And I have no idea how loud the sound's going to be. So if it's really loud, I'm sorry. Okay, that's enough. So if you followed along with the music, you did see little moments where there was sort of like a kick and like you would see the thing sort of spike a little bit. And you would also notice that when he was singing, there would be like some smoother transitions in the video. And that's just, again, it's basically what it's done is it's analyzed the audio and it's able to apply those various pieces to this video. Now, the challenge here is that one, our audio is all a jumble of both drums and bass and keyboard and song. And the problem is like we've got a stack of audio and it's trying to analyze individual components of it, and it's going to struggle to do that. So what we're going to do next is we're actually going to pull our audio apart using a tool called Demux. And then what we'll be able to do is we'll be able to tell Lucid Sonic Dreams to look at just the drums file and apply the percussive part just from the drums. And then we'll take the vocal part and we'll say just apply the motion to the vocals. So this is a cool trick that I highly recommend you do for something like this. It's just it helps because you're able to, you have a much cleaner signal. So we'll look at how to do the Demux in just a second. Demux is just a machine learning model that allows you to take a song. It's basically been trained on all the individual components, individual tracks of a song, and it learns how to basically combine them and pull them apart. So I should say it is not perfect, but it's going to be really good for what we're going to do here. So the way to use Demux is to run this cell, which just installs all the tools. Once that's done, then we can take a look at what the help. So this is the command to actually do the Demux separation. So if you run this, you'll see, so basically we pass in -n, so we'll need to figure out what that is. Out must be an output, and then there's models, there's a bunch of stuff here. So I have to say the way that Demux is set up is very confusing. I don't love any of these names. So I'm just going to skip ahead and show you how this works based on their documentation. So one thing to know is that there's a bunch of different models, just like we've looked at, you know how in body picks there were different models of different quality? The same is true of Demux. So there's a list of a bunch of different models available. If you click on this link and then you go down a little bit from here, you'll see, man, really far down. Where is it here? Here. So you'll see there are a couple pre-trained models. So there's Demux, Demux Quantize, Demux Extra, Demux 48 HQ, TASNet, and TASNet Extra. So you can read through these and it'll kind of tell you what each of them is. So these first two are optimized to be a little bit faster, but they'll be lower quality. Demux Extra and 48 HQ are supposed to be higher quality. So again, maybe for this process, because we don't need real time, we'll use one of these. And there's a couple others here. So if you're interested in learning more about Demux, there's more stuff here. But I'll just show you what I think maybe works best for most of the stuff I have. So we'll come back to our notebook and we'll see here that we're just going to run a command called demux.separate. We're going to tell it where to save our files, which is -o. So it'll create a folder called demux_separated, and that'll be generated over here. We're going to use our model network called Demux Extra. Again, this is one of the higher quality ones, which means it'll be a little bit slower, but it should give us a better separation quality. And then we're going to save it as an MP3 with a bitrate of 320, and then we're just going to pass it the path to our song. So if you have a different song here, you should just copy the path and come over here and just paste it. I should also mention that if you have spaces in your file name, you will likely want to wrap your name in quotes. So you want to do this. So in general, try to avoid having spaces in your file names. You always create other issues, but you can probably just wrap it in quotes if not. So we'll go ahead and run this cell. We'll see what happens. This again might take a minute just because we need to download like a gigabyte of files. So that'll be a little bit slow, but it should work for us. All right, actually, while this runs, let me show you what it produces, because I've already saved it down to my computer. So let me just come over here and go to my files. And so what it'll do is it'll produce a folder. I'll show you in a second what the folder looks like, but it'll be Demux separated, and then there'll be a bunch of subfolders. But at the end, what you get are 4 files. You'll get a file called bass, a file called drums, a file called vocals, and a file called other. Other is essentially the melody or the like non-bass music part of your track. Or there might be like audio, like effects and other things in here. It's kind of a bummer that the other is kind of a mess of everything else. I wish they had trained like a audio effects or just like noise channel and then done a melody channel, but beggars can't be choosers. So let's just open these and listen to them really quickly. So let me open drums. So not bad, actually. I mean, you can hear like it kind of sounds a little like tape hissy, and that's just because it's trying to like process all the frequencies. But in general, like that's fairly good, and will definitely be good enough for what we're going to use it for in this tutorial. We can also listen to the vocal track really quickly.
You're my heart, empty love, empty love, empty love. It's empty love, empty love, empty love.
So that one kind of has a robotic output, but again, for what we need it to do, which is just that process that particular signal, it'll be fine. So the nice thing about this is we can use these tracks to control various parts of our model. And then at the end, all we do is when we output the actual video, we just use the original audio track that we started from. So that way we just like, no one notices that we've got these noisy tracks that we've been separating for. So this will work really well for us, even though those things are a little bit noisy. I will say this doesn't work perfectly for every song. In general, if you have vocals, bass, drums, and melody, it'll do well. I find it tends to work better for like sort of rock songs or pop songs, and a less better for like jazz or heavy electronic stuff, just because usually there's a bunch of different kind of tracks in there and it doesn't always mix correctly. So you might find it doesn't work perfectly for you, but I do find in general it works fairly well. Okay, so this is finished for me. So you'll see up here in this folder there is Demux separated, and then there is Demux extra, which was the name of our model, and then is our actual file folder name, and inside there are our tracks. So let's start with, basically, I always recommend starting with motion. Motion is like the biggest part of this model, right? It's the interpolation between various components or various images. So the first thing we're going to do is we're going to change how we wrote this first command. So before it was just this. We had a song and a style. And now instead what we're going to pass in is we're going to pass in individual audio tracks. So we are going to say, basically, we don't want any pulse audio. For motion audio, we want to have it track the vocals. So we can come over here and we can copy our path. If you don't have vocals in your song, okay. Did it just kick me off? That's going to really suck if that happened. It did. Okay, 1 second. I wonder if, you know what, I'm going to switch to my non-free version. I think this will just work a little bit better for me. And that way, if I'm talking, it doesn't kick me off. And hopefully it doesn't give me an A100 because I can't use A100 for this. All right, cool. So let me just quickly run these just to get us back to where we were. Upload my song. And actually, I'm just going to upload the individual tracks. So let's just upload this. And we'll skip this one and we'll jump down to here. Okay, so just know that your path will probably be different to your audio files than mine will because I just uploaded my own. And let me upload my full song as well. So that was this song. All right. So once again, you will point the main song. So also for this example, what I did is we want to look at just the vocals isolated. This tends to be really helpful just so you can see what is actually changing. So for this, what I'm going to do is I'm going to copy them with the path to my vocals. And for both the song and the motion audio, I will use that path. And then I am leaving the style as abstract art. And then what we're going to do is we're going to create a file that is just the vocals connected to motion. So if you want to keep this name, you can. And then we'll go through these variables one by one. So we'll see, again, we did start. Just going to do 10 seconds. And again, here's where we're going to use speed FPM. So the way to think about this is this will generate 12 images and interpolate between them. So if you want it to feel slower, you'll want to make this like 8. If you want it to feel faster, you'll make it 24. That just gives it more images to interpolate between, or morph between, if you want to use that word. So I'll make this as 8. And then you'll see here that there is motion reaction. So again, this is how much we react to this audio signal. So we can make this really strong and do 2. The average is 1. You will also notice that I've removed all of this. So this like pulse percussive, pulse harmonic, motion percussive, when you set these variables, the motion and pulse here, it basically invalidates your need to use those other tools. Like I've included them here just to make sure they're off, because I want to make sure that when these are set to none that it doesn't work. But basically, if you include this audio, it'll just assume that whatever you're doing is being tracked to motion. So it's always going to look for this when it's set to motion. Truncation. So for those of you who are familiar with stylegan, this is a truncation variable. Truncation just means how different or realistic the image is. I would say if you want to play with it and you haven't done stylegan before, do something between 0.5 and 1.0. Anything less than 0.5 means you might not get a lot of change in your images. So I would just say, like, let's just leave it at 1.0 for now. And then lastly, we're going to skip any of the pulse stuff. So we're just going to look at how the vocal track can affect motion. So let's go ahead and run this. I don't even know what GPU I have, but it should be much faster for me now. Oh, so it's going to need to re-download this model. So much faster on a V100. Oh, so Emily, oh, it does work on A100. That's good. I've always had issues with stylegan on A100s, but it's great if it works. So Emily mentioned that, yeah, if you do swamp sounds and things, like it has no idea like what to move around, so it's just gonna try to put things in the right categories. Just remember, it was trained on uh, like like pop songs, so it like only knows that. So other things it might pick up as frequencies, and it'll able to like move them around. But it will probably just do weirder stuff around what is what sounds. So yeah, it'll probably take frequencies since that's essentially what it learns, but you won't always get exactly what you expect out of that. Okay, so maybe this isn't faster. But yeah, it's definitely faster. Instead of taking it a minute to render all my frames, now it's taking 20 seconds. Cool. So after that finishes rendering, we'll take a look at what the YouTube video looks like. Oh, I have to run another cell up here. 1 second. All right, so let's watch just vocals in motion.
You're my heart, empty love, empty love, empty love, empty love, empty love, empty love. Rushing through your veins, take my blood, cut me up, and find a way to tear ourselves apart. Living with empty love, wherever we turn, we will never overcome.
All right, so you can see because it's only looking at that track and it doesn't have a bunch of other noise, when he stops singing, the whole thing slows down, right? So like as he's singing, depending on how he's hitting different parts, you can really sort of see the animation happen. And then when he's not singing, it like really slows down. It's kind of beautiful, like how nicely like that animation curve works. So that's why it's helpful that if you can separate your source tracks, that you do that. Because that other one was so much muddier because there was singing, there was a bass track, there were keyboards, so the audio frequencies were just kind of all over the place, and it just was sort of like animating at best it could. So that is just purely matching vocals. Now you could, let's say for whatever reason, if you have a really bass heavy song, or if you have, maybe there are no vocals in your song, you just want to use that other track, you could change the path, right? So if we wanted to look at just the melody, we could switch this to other. So I recommend when you play with this throughout the week, like maybe try swapping out different tracks and seeing what changes. Also, just we're running a little bit late, but you can also try changing the value of this and trying different variables. If you don't have content, so this is a great point. Because I didn't append content here, we are actually in this folder right now as we're operating. So if you open this folder, you'll see here's the file. So this is my fault. If you had, next time when you run it, if you do /content, that will put it in the main folder. But it should, if you ran this cell with just using what I had there, it'll be in this Lucid Sonic Dreams folder. Cool. Okay. So we've now looked at vocals. So why don't we look at actually using the pulse percussive? So in this next example here, what I'm doing is I'm mapping our drums to the pulse. And then for this particular example, I just want to take a look at what the drums do to my track. So what I've done is I've taken the drums and actually need to update these paths from on my end. So we'll do this, it goes here. And we're only going to feed the drums into the final output because I just want to see what the drums change to this particular model. The other thing we're going to do in this example is I'm going to set the speed FPM to 0. Remember that what that means is there will be no motion animation. We will just get a single image. And what this will help us do is we'll get the single image, and then we'll also see how the pulse reaction changes that image. And that's just going to give us an idea of how the song is going to react. So because we're running a little short on time, I'm just going to go ahead and skip running the cell. You're more than welcome to. And I'll just run the YouTube demo and take a look at it. So remember that this is just this one image, and the pulse percussion is sort of that little change you see. So you'll see it responds a lot more. Oh yeah, there's probably a content. Thank you. Content. Yeah, if you didn't catch it, update that. So we'll see that the kick drum affects it a little bit more than the snares. This is a case of where I can't really control that. If I wanted to control that more, I would look at something like the audio reactive notebook that I taught in a previous class. So if that's something you want more control over, we can look at that. But for now, I'm sort of just going to deal with what we get. Now, this pulse reaction was set to 1.5. You could crank it up a little bit more and it would be a little bit stronger. The guy who made this notebook said don't go really above 2.0. I'd imagine because it's just going to make your images kind of like messy and gnarly. But you can play with it and see what you produce. If you want something more subtle, you would do something like this. So you can do whatever floats your boat there. Cool. So that is a video that we've now produced. So this other video, the next thing I want to do is actually just combine these things together. So all this does is take the motion parameters of the cell above this one and the pulse parameters from the previous cell and sort of combine them. So here again, what we'll do is we will copy vocals in here and copy the drums over here. And if you want to, you can generate a output song that is both, that combines both the vocals and the drums together using this cell above here. So the way you do this is you pass in both parameters. So this is the drum track and this is the vocal track. And then what we want to do is we want to save that out to a secondary track called vocals plus drums. Diego, go ahead.
Can you feed two different melodies to that cell instead of a drum and
yeah, you could
get like a mix of the melodies?
Yeah, exactly. So this is just an FFmpeg command that combines two audio tracks together. So you could put in whatever two inputs, like basically -I and -I are the two inputs, and you just mix in two tracks. So like when I do this, this will just generate one single track that is both vocals and drums. Refresh over here, and I got vocals and drums. So if I want to view this with the combined two elements, which is kind of nice, just sort of see how both those things combine together. It's a nice little trick to be able to do that. So again, I'll skip that one here. If you want to render out yours, you're more than welcome to. I'll just play the YouTube video and we can watch and see what it does when we combine those two.
Fill my heart with empty love, with empty love, with empty love. Empty love, empty love, empty love, rushing through your veins.
So you saw we got the motion applied from the song, from the vocals, and we were able to do little kick drums here and there based on that. Diego, go ahead.
Okay. And can I use, for example, two models, abstract art and another one? At the same time?
You can't really use two different models for this because of the way that it generates images. You can only generate images from one model. What you could do is you could do multiple different passes of this, and then like using After Effects or FFmpeg, combine the videos together, like using like a blend filter. But yeah, there's no way to combine two models together, or the way to do it is trickier than I want to cover for this material. So Kaiman asked, do SG3 models work with this? Not with this particular notebook. I know that someone has done Lucid Sonic Dreams for SG3. So if you have a stylegan 3 model, let me know and I'll drop a link in for that notebook. A guy on YouTube called Nerdy Rodent has updated the Lucid Sonic Dreams. Basically, every time we get a new stylegan model, like little things break and someone has to go through and update them. So he went ahead and did that. So I'll share that notebook for anyone that has a stylegan 3 model. This notebook will work for anything stylegan 2 or lower, and basically anything that is PyTorch, TensorFlow, whatever. It'll all work with this one, but you do need something different for stylegan 3. Okay, the last final touches here is there are a couple other effects that are available within Lucid Sonic Dreams. Contrast, which just adds a contrast filter to the image. And then flash, which, as you might imagine, flashes the image a little bit. So here again, we can sort of apply whatever we want with this. I went ahead and basically just did another video that only singles out those particular pieces. So if you want to see what it looks like with it just singled out, where again, we just have one image and we're only seeing how the contrast and flash are taken from the drums and applied to a video, that looks like this. So, you know, nothing too crazy. It just does a little bit of flashing here and there, right? And these also have a strength indicator. So you can say I want to do contrast to 1.0 and I want to do a flash strength of, this probably was 1.0 as well. I might have just updated that incorrectly. So you can apply this and see, oh, this is just for contrast. If you want to see just contrast, maybe that's actually what this is. Yeah, this is just contrast. I actually don't find that contrast and flash do much together. Let's see, this is contrast and flash. So let's see how different they are. The flash does apply a little bit. It adds a little bit more of a color change. So once you have all those pieces, let's say you want to use all 4 of those, then you can actually do this last cell, which combines all of them. So again, I'm taking the drums and mapping that to both pulse, contrast, and flash, and I'm using the vocals to apply to the motion audio. And the last step here is that I'm taking my song. I need to update all these paths. 1 second. And then I believe that song is right. So I'm actually going to use the full output, my full MP3, as the final song. So this will essentially just sort of say like, use this for tracking, but when you actually generate the final video, just use the full song. And that looks like this.
You're my heart, with empty love, with empty love, with empty love. Empty love, empty love, empty love. Rush.
So I could have said, well, maybe I want to map contrast to the bass track or the melody track. This is kind of where it's a little bit up to you to have some fun with it, because a lot of it depends on your song and what you're trying to do with it, right? These are the 4 effects that sort of come pre-packaged with Lucid Sonic Dreams. There is also a way to write your own effects if you know how to either use Pillow or write some other things. Like there's an example in this notebook. Let's see, all the way at the bottom here, using custom effects. So there are ways to apply a custom effect. So I guess if you want to do something like swirl, what does this even use? Oh, this uses a tool called scikit image. So there must be a swirl function in scikit image to maybe like swirl your image. If you want to apply custom functions and you know how to do that, either using scikit image or Pillow or other things that are like image, like NumPy based, you could do that using this. that will definitely not be covered in this class, but if you're interested in learning more, we can maybe talk about it during co-working. So there's a lot of things you can begin to do with this. I would say my personal feeling is that if you reach a certain level of customization, you want to jump over to that other notebook or those other tools that are the audio reactive stylegan tools. Because I think this one works well up to a certain point, but then you don't have access to the individual audio and you can't like do filter bypasses and stuff. So it gets a little bit trickier. But I do think I think just making sure you separate out your tracks and begin and apply that to just the individual tracks is a huge start. And it's kind of why I see a lot of people just run Lucid Sonic Dreams, like just upload a song and run it through it, and like I find you always get muddy results. So doing that extra little step of source separating and then being able to apply things to individual tracks tends to always make you can actually see it like audio reactive moving to the music better. Yeah. So I ran through that a little bit quickly. Any questions? Another trick I'll say is like you don't have to use the end audio track, right? If you want to do just interpolation, this is a cool way to do just interpolation, just feed it like a single like singer, and then animate using that, and then just play it silent. You'll still get cool animation out of that. Any other questions? None. Okay. That's cool. If you do have questions, if you have to start playing with this and you want to ask, let me know in co-working. Well, why don't we do this? We'll take a 10-minute break. We'll come back well, let's just do 11 minutes. So we'll come back at 8:40, and then we will look at how to use p5 and ml5 together, and we'll make a weird synthesizer tool. Sound good? All right, see everyone in 10-ish minutes. Oh, so Ben asked if we use that pickle file, the padded trees one. Yes, what you can do is you can just include the path to the pickle file instead of that string. That's correct. Yeah. So yeah, if you find another pickle file on the internet, or if you've gotten one from me through Patreon or whatever, like yeah, you can just use those and import those there. Okay, before we jump into the P5 ML5 stuff, I just want to mention, let me share my screen again. So again, I have a list of videos for us to watch next week. So next week's theme will start to be cinepoetry or cinematic poetry, whatever you want to call it. These are films that have some relation to the concept of poetry. I will say this is probably the section I feel least comfortable teaching. So we started with a couple. There's just a couple like very obvious films in here. If you haven't seen Meshes of the Afternoon or Unshin Andalou, those are like two of the most famous experimental films. So we'll watch those. That way we all can talk about them. And there's just a list of other films that are either very clearly related to poetry or tangentially related. So take a look at these. Most of these are a little bit longer than last week's. So give yourself a little bit of time, but I think they'll be interesting, or there'll be things to discuss from them. So just remember to watch those. And then for next week, what I would say for your homework is to watch these and then bring in one like sentence of interesting text. So we'll do something interesting with one sentence of text, and then we'll play with stuff for the next week and a half on it. Sound good? All right, let's dig into ML5. So I mentioned in Slack the other day that the ML5 repo, Steve mentioned this, and it's a really great opportunity. So a lot of the stuff that we've been looking at in this class in Colab takes time, right? It takes time to process stuff. But there are a series of machine learning models that are meant to work on mobile devices or meant to work more real time. And one of the nice things is that the ML5 group, which is a team of, I believe, ITP grads, probably like under the direction of Dan Schiffman, have been sort of figuring out how to integrate that into a really simple JavaScript framework. I know in particular the Google folks are very interested in machine learning on mobile devices. So, you know, being able to take a photo and apply machine learning to it, or real-time video, that sort of thing. So ML5, I actually haven't looked at ML5 in 2 years. And when Steve recommended it, I was like, I don't know if there's anything here. And then I looked through it and I was like, there's actually a lot of really nice tools in here. So what we'll do is I'll just quickly go through like how you might find an interesting tool in ML5. And then I'll show you an example that I quickly built today, actually, well, yesterday and today, to like build a cool little like interactive synthesizer kind of thing. So this is the link to the ML5 reference. The challenge here is that it's helpful to remember that anything that is built for the web or for a mobile device is generally going to be less accurate but faster. So in the case of real-time applications, you'll generally get a better system out of this. It'll work okay. But the example we'll look at today, we'll definitely see that like it is not super accurate. And that's just the downside, or like the pro and con of using these sort of devices. At the top of the references, there's just a getting started, there's an introduction, and then there is a list here of sort of different tools. So we've got some helper classes. So if you just want to do, you know, a basic like either a classifier or a k-means construction, we can do that. Don't really need to worry about that. I think what we're going to look at is just like the tools available to us or the models available to us. So you'll see each of these are broken up into sort of what they do, or like the data they process. So we have a section of images. You'll see here our body pics tool from last week or the week before is here, as is a couple other things. So in general, I would say like doing a GAN in a model in a web or mobile tool seems kind of tricky, but I guess they do have a DC GAN here. DC GAN is like 6 years old now. I wouldn't necessarily use it and expect good outputs, but if you want to play with it, you can. What we're going to look at today is we'll look at hand pose. So we'll do a live video camera and then track a hand. But there are other tools here. So PoseNet is like Dense Pose or like the other things that we looked at, where it'll track a body pose, give you a skeleton. Image classifier, so you can probably pass an image and get back a particular class of what it thinks is in the image. UNet actually is, I believe, a object detection model, and it does segmentation. This is not a good example, but this will help you. So I think maybe Sean, maybe you were asking about object detection. This might be a good one to play with. Hand pose will do skeleton, but for hands. Face mesh, I assume, will give you a look at your face and give you all the various meshes of it. Face API might return face and face landmark detection. So it kind of does like a mix of detecting a face, and it'll give you the landmarks of the shapes of your face. Style transfer, so you give it 2 images and it will produce a style transfer. This was based on fast style transfer, so I wouldn't say, if you've done style transfer with me, I wouldn't recommend this, but if you want to play with it, you can. Basically, what I imagine will happen is it only works with a couple of images, and does that well. Pix to Pix should allow you to do stuff like drawing outlines and get Pikachu. I imagine there's only certain models available, like maybe just the Pikachu. You probably can't train your own through here, but it's interesting. CVAE is probably okay, there's no images here, but it's an audio encoder, so it should essentially be able to create new faces. DC GAN can probably also, again, depending on what model you have, can generate new images from it. Sketch RNN allows you to create new drawings, and I think I'll try to complete them. If I haven't used Sketch RNN in a minute. And then there's an object detector. There's also sound, so sound classification, so it might be able to guess like what animal made a sound. Pitch detection, which could be useful. Like let's say you want to like feed a melody in and do something with that melody, being able to detect the pitch could be pretty helpful. And then there's a couple of other text tools here. So there's a fair amount of options here. I feel like they've added a couple of these since I last looked at it. I believe it's probably some ITP grad students like thesis project or something to like add a couple of models to these every year. So there might be new models coming out every day. Who knows? So the trick here is that the challenge here is just to make sure that you move it into P5 correctly. And usually what you just need to do for P5, so let me just open up a brand new P5 sketch. Let's see, I want editor. So when you open up, oh, that isn't what I want. I want a new sketch. File, new. So this is what a default P5 sketch will look like. And usually all you have to do is come over here and go into your index file. And you'll see here that we have p5 and p5 sound. What we'll want to do is we'll add a new script. And let's come over here. I bet you there's something like getting started. Yeah, so here is the script we want. So you just take this script tag and you paste this in here. And now we have a link to our ml5 model. Now from there, you need to sort of go through this getting started and making sure that you're accurately getting the right details back. So let's look at body picks, which is something we learned previously. So if we come in here to body picks and we see get started, usually what you can do is you can copy this code directly into your sketch. Let's add it below here. So we're saying that we want to use the body picks model, and then this callback function of model ready says when this model is loaded. It usually takes a little bit of time to load in one of these models because they're pretty large. So once it's loaded in, then you'll get a function that says like, hey, are you ready to use this? And then you can say like, once I'm ready to use this, you can do this. And this will run the body pick segment, so you need to pass it an image. And then when you get your results, it'll say got results, and it looks like it'll return. Looks like it just returns a background mask. So this is where I might need to go in and read through this these parameters a little bit more. It looks like it can return all of the various components, and it looks like it returns them as color shapes. So I would probably say that the demo we used in class was easier, or like in that collab notebook, because we actually access the individual shapes, but there might be a way to do that through here. I would need to read through this a little bit more, but the other nice thing is there are examples here. So if you go to P5 web editor and you go to P5, let's just do body picks image. There's an example here. So you can go ahead and hit run. And what it did is it loaded in an image, and then it returned the mask, and then it places that image, that masked image, on here. So this is pretty cool. This works relatively quickly, and it looks like they also had an example here where you could do this with webcam. So we could try webcam parts. Oops, that's not the right link. Make sure you click on the P5 web editor. And let's run this. Now back up, we'll see if this works. Okay, so there you can see, remember that body picks gives us half of the shape. So it gives us half of our head, gives me the torso, shoulders, arms, and if it works, well, remember how it does a terrible job with arms and hands? Here you go, it's terrible arms and hands. Now you'll also see the refresh rate on this is very slow. This is the challenge of doing anything with mobile web or real time, because it is not very fast. So if you were going to build like a real-time thing using P5, you would need to figure out how to actually work with this, right? Maybe it's like you do some blurring, or maybe you're trying to interpolate between the shapes. It's going to be kind of tricky. So this isn't perfect, but it is sort of interesting that you get all this stuff and you can work with it. Cool. All right, so what I'm going to show you is I took the hand, there's the hand pose tool. I took the hand pose tool and kind of, based on what we maybe discussed previously, I did a little thing where I made a little reactive audio tool. So you should note this uses a oscillator, which is built into P5, which makes it sound super like analog synthy and also kind of gnarly. So just beware that the music we're going to make is not going to be great. But before I run it, let me just break down what we're doing here. Well, actually, let me run it. We'll look at it, and then we'll come back and break down the code. So let me share this with everybody. You are welcome to copy this and then play with it, do whatever you want to do with it. I am not number one, I am not a musician. Number two, I did this very quickly, so it's a little bit down and dirty. So these sounds will be kind of gnarly, but if you know enough about music and enough about signal processing, you can probably create like cool tritones and other things by playing with this a little bit. All right, so let's run it and let's see what happens. Okay, so you'll see on the screen I have these 3 circles. Or 3 circles. I have 12 circles. So those 12 circles are the major tones of a, they're like, I don't know, they're 12 tones. Let's just say that. And when I move my hand, when my hand crosses over one of those circles, the sound coming through? Okay, cool. So that's just how this works, right? So basically it takes little dots and it tracks them. So let me just stop this real quick and we can break down what's going on here. So the first thing I needed to do is I needed to do the hand tracking. I actually just pulled all the hand tracking code directly from what they gave me as an example. So in our draw loop here, there is a draw key points. And what that does is it calls the hand pose model. So up here in our setup, we call the hand pose model. So ml5 hand pose. And then when it's ready, we do our predictions. And those predictions get saved to something called predictions. And then when we do the drawing of our key points, similar to what we do with open pose, it loops through our predictions, and then it loops through all of the key points or landmarks in that position. So if I turn off, let me turn off check dots, and then hit play. And this again usually takes a couple seconds. You'll see the video actually freezes when you run it. So now you'll see that it gives me all these points in my hands. Now I dug around to try to find documentation on what order the hand dots come in. Couldn't find it. So if we want to play with this more, we can probably just turn these numbers on and off until we figure out what the order is. But you'll even see, like, you know, this isn't the most accurate thing, right? It doesn't really like find the perfect center of my fingers. But it's also pretty fast, right? The refresh rate on this is pretty good. So in general, you know, not great, but like it is much better than I would expect for real time. I also noticed that sometimes when I move my head around, sometimes it thinks my head is a hand, which I don't know, maybe that says something about me. I won't take it personally. I also noticed that it doesn't do both hands. It's supposed to, but for whatever reason, it doesn't do 2 hands. Maybe I did something wrong in this loop. We can play with that and maybe find it later. But this is how you just get back that code. So from there, what I did is I wrote a little script. So I call these wave dots. And I wrote a little script in our setup function to generate. So basically there's also a tone count, or like how many of these do I want to make, and then a starting frequency. 220 is A3 for those of you who are musicians or sound people. So basically what I'm doing is in my little loop here for all of my counts, I create a wave, an audio wave. Oh, this is a saw. That's probably why it's kind of weird sounding. You could also, there's a bunch of different wave types. You could do a sine function, or a sawtooth, or a square wave, or other things. And then this is where I set the frequency. So I looked this up. The way to do frequencies, if you want to go up a single tone, is to take your starting frequency and multiply it times the power of 2 to the 1/12. So this actually skips the like sharps and flat notes and just does single, like the white keys on a piano. So this creates 12 of the white keys. And then those circles happen because I've got this little circle generating function that goes around in a circle and generates my 12 tones. Those all get saved to a class, and then there's some code in here that actually checks to see if my finger is inside of the dot. So basically takes these key points and it checks to see if those key points are inside of a circle. And if it's in a circle, then it plays that note. So that's the really basic version. Again, I would say if anyone wants to talk more about this code or has an idea on how to change the code, I'm happy to sort of help you break that down. Another cool thing that I came up with is we could also try just a random version. So what if instead of having that perfectly circular setup, what we could do is we could just, let me hit stop here real quick. We could take all of this, and if we turn this on and turn this stuff off, what this will do is we're going to create a random circle width or a random circle radius, and then we're going to randomly put it on the screen, and then we're going to display all those. So we're going to get as a bunch of little dots on the screen at various sizes, and then we'll be able to sort of move our hands over them and get random noise. So let's just run this and we'll look at what this does. Oh, I turned off our draw loop. So down here is this check dots function. That's what actually draws our dots and allows us to play sound. So let me run this again. So see here, there's a weird cluster of all of my dots. Also, this is like backwards, so I'm like very confused. It's like playing with like glasses with water in them. So as I mentioned, this is very down and dirty, right? This sounds kind of gross. If you were to maybe actually figure out how to write chords in this function, you could actually do some sort of chorded melody, or maybe what you want to do is like you could cluster one chord in the top corner, another chord in the bottom corner, or and then play like using that. The other thing is there's a library called tone.js. And this allows you to basically write like little beat loops or other things. Let me see if there's a good example here. Okay, let's see if we've got something else here. So I have never really played with this too much, but there's also samples. So you could actually run, instead of just generating like a tone using the p5, you could actually run like individual samples. So there's a lot you could do with this tool once you begin to add it up. Tone.js, I believe I've seen an example here. Let me just pull it up. Tone.js, p5.js. And so for this example, what you can do here is similar to the other one, to ml5. There's just another script here. So if you want to include tone.js, you just take this script and you add it to your index file. And now you have access to tone.js. So we could come back over here and let's see what they did in this example. So sketch.js. So this gives you like almost like a little player. So let's play this and see what happens. Nothing happens. Okay, maybe that doesn't work. If it's possible that you can't use tone, let me just take this URL and see what happens. Okay, so that does still work. So not entirely sure why this doesn't work, but you could essentially like add this together. I believe P5 also has an audio player. I don't want sound synthesizer, I want sound library. Let's see what this does. So you could think about like uploading your own sounds, and then what you would do is you would trigger the sound using song.play. So if you load in a sound and then you use song.play in this function, in our sketch here, the way to play something is using if this should be playing, run this. So you could actually play a value using this. Or sorry, this is not playing, this is playing. So basically you would put a stop function here and then you would put a play function here. So you could begin to build up like a little library. The challenge with this particular structure is that there's no way to keep things in sync. So if you have like little loops of like a drum loop and a bass loop and another thing, this will not sync them. So you have to have some other control to sync stuff. But this will allow you to play like little individual instruments. So you could have like a little drum set and you could have your fingers wiggle over the drums to create different drum sounds. So there's a lot you could do with this. You could also, instead of attaching this to hand pose, you could attach this to, shoot, I lost ml5. Because those are just key points, you could use PoseNet and actually get body position. So you could play like, you could have a dancer, and as it dances through the space, it could set off different tones. You could use the face mesh, which gives you all these poses, but actually I guess you would, instead of face mesh, you would want face API. Face API is going to be a little bit better to get these individual landmarks. So you could use your nose and your mouth to hit notes, which could be kind of fun. So there's a lot of ways to build up this tool, and the challenge is always just like, how do I take this data that I'm getting back from this model and using it in the right function, or using it in the right way that's appropriate. So it looks like, let's just look at an example here. Image landmarks. So this will run on an image. So let's just run this really quickly. Okay, so there's our image. If we want to switch this to a webcam, we can just do this. We'll do video equals. So in setup, we'll do this. And I believe we want our capture to be this. So we'll do this. Oh, there's no draw loop here. Interesting. Okay, so setup, so function, draw. And I believe we will want to say, let's just say let ready equals false. And in here we will set a ready equals true. And we'll say if ready we want to apply our face API detect single to the video frame. Let's see if this works and I didn't break anything. Oh, what happened there? Video size. Did I not set a... Ah, here we go. Create canvas. Okay. Okay, so I broke something there. So we can come back to this and take a look at it. But essentially you could use the face key points to animate stuff. So maybe what I'll do this week is I'll go through and add a way to use faces versus using hands, and then we can just set a flag in here that says, you know, use hand or use face, and then you could switch between those two. Actually, we could probably do both. So you could actually like do something where you like record your hand and your face, and then you've got different parts of it. I don't know how well that would work, but we could see it. Naoko says her camera doesn't connect to it. It might be because you're a PC. Yeah, if you don't have a built-in webcam, you might need to play with this create capture function. Like, let's see if p5.js remote camera. Oh, that is not what I expected that to be. That is only for, let's see. Oh, that's processing. Okay, I can find it if we can't figure it out. But yeah, so we should be able to set you up with a video. I think what you might have to do is, wait, what is? Okay, let's just look for create capture, P5. Sorry, when you turn on the web camera, it crashes your machine, especially when you've got that and zoom going. Let's go to reference. You might also be hitting this, which is there's sometimes security issues with trying to play through a webcam. So yeah, we could probably look at this and try to figure out what's going on. But sometimes what you have to do is you have to set like it to a 0 instead of video. There's probably just something we have to set, and we can sort of Google around and see if we can figure that out. Yeah, so that's sort of what I got for this one. So I don't know if anyone has any questions or thoughts, or like, again, if there's ways you want to tweak the parameters that I can do this week to get something up for people, I'm happy to talk about that. Questions, thoughts? Yeah, I think hand pose is supposed to take 2. I was trying to look at the original documentation for it. Oh, here you go. It can detect a maximum of 1 hand at a time. So that is just what we get. I wonder if there is a hand pose. Let's see if the original hand pose gives us more than 1. Yeah, it looks like it only does 1 hand for this as well. So there might be another model out there that could run on TensorFlow.js that allows us to do more than 1 hand. So I should mention TensorFlow.js is generally what is the backbone for most of these things. Again, TensorFlow, which is a tool from Google, tends to be the most common thing you'll use, just because they tend to be more interested in mobile devices than Facebook, which runs PyTorch. But you can see what models are here. So hand pose, pose, blaze face. Okay. Deep Lab is an interesting one people might want to play with. That allows you to do segmentation of different images and give you semantic segmentation. Means it'll give you back what the classes are of each of those segmentations. Base landmark text. So it actually looks like this is pretty much everything that ml5 has built in. But there might be other TensorFlow models that are not officially TensorFlow based that you could play with. So, and usually like something you might want to try is just TensorFlow.js hand detection. We can just see, let's try multiple hand detection. Multiple hand detection. So what is handtrack.js? Okay, well this is interesting because this is one of the things you often find is that some people have just like a bounding box, which is a hand detection, but it's not a hand skeleton. So this is always the challenge with a lot of these tools is like, okay, what do you get? And do you get the individual key points? This could be interesting if you wanted to have, say, just have like two big sounds or like two big things, and you just want to see if a hand is in those instead. Yeah, it looks like maybe multiple hands is a unknown variable at this point, or unknown tool. It might also just be that it's just not possible for mobile use. Multiple hand skeleton TensorFlow.js. This is basically what I do all day. When people ask me like, does anything like this exist? I just Google it to see. Seeing a lot of the same. Yeah, seeing a lot of the same things. So I'd have to dig around more. But one hand is okay. The other thing I would love to do is maybe just get just those fingertip key points, because I find that when you pass over that thing, it gets really messy and gnarly. And maybe if we were able to do just the fingertips, we could do something like kind of more fun with that. So that might be something I look at this week as well. Any other questions? Maybe not even relating to this, but just like to anything else we've covered in audio reactive or sort of the sound course so far?
Yeah, I kind of have a question. Just if you have seen anything of the sort of like the harmonic percussive decomposition for like live interactive systems, because right now all the stuff was offline.
Yeah, I've seen, I think there is a Demux that is real time. So I think what you could do, like you were talking about the Demux thing, right?
Yeah, for example, or just a simple harmonic percussive, because I've tried using Labrosa and that's pretty like still very slow.
Yeah.
Yeah.
Interesting. I haven't seen
Like
anything like that recently. I have seen people use Librosa real time, but this is again sort of maybe outside of my scope of expertise. But I have seen people do it. I don't know if they're using a different version of Librosa or if they are maybe using a different tool. Like I know, so the guy who made the audio reactive tool that I taught previously, his name is Hans, and he is, let's see, it's wavefunk underscore. I can ask Hans. He's actually in our Slack like fairly frequently. I can ask him to see if he's got anything that is audio reactive real time with Librosa. I think he does his stuff real time. I haven't seen any of it recently, but I'm fairly certain that he's using some sort of real time to do this tracking and that sort of thing. And the backbone for all this is Librosa. So I don't know. We can ask him and see if he's got any tools or tips or tricks. But real time is always a challenge because you're just trying to process a lot of data really quickly. So usually what'll happen is if it's real time, you often won't get every individual detail of a thing. You'll get like the big high notes and you have to sort of keep track of them, or the frame rate will be off. You'll have to sort of hope that the frame rate syncs to whatever song you're playing or that sort of thing. That's why I tend not to teach as much of it. One, because I don't do a lot of real-time stuff, so just like out of my wheelhouse, but also just it does tend to be a little bit messier and you have to like account for all that messiness. Whereas what's nice with sort of offline use is that it's always more accurate and you can just do more accurate stuff with it. So I'll ask Hans and see if he's got anything, but I haven't seen anything recently, but I'm sure someone's doing something with it.
Yeah, thanks. That would be great.
Yeah. Any other questions? We can wrap up actually at 9:20 today. How amazing is that? Finally, don't go over for once. Cool. So yes, we'll wrap up here. Again, if there's anything you've seen or want to play with and don't yet know how, please just shoot me a DM or let's talk over in a co-working session. As I mentioned this week, I will actually like fix some of the Vidum stuff or add some of the new features. So I'll let people know in the Slack channel when that's ready to go. Yeah, and then just again, remember for next week, watch all of our films and then come to class with a cool sentence and we'll go from there. Sound good? All right. See everyone next week.
Thanks, Derek. Take care.
Yep. Bye, everybody.
Thanks, Derek.
Bye.